you'll come across terminologies that have been used before. Just that I know some may have forgotten, but then the few that you remember, we just make very good use of it. Is that okay? So, but then the first thing I want to find out, uh, when we say surveying, or you might have heard of the word, oh, this person is a surveyor, this person is a surveyor. When you hear of surveying, what comes to mind? Once you hear of the word surveyor or surveying, what comes to mind?
Then
Yeah,
taking measurement of a space.
okay. So when we talk about surveying, we look at taking measurements of a space. Okay, that's good. Any other? Is there any other, please? Okay. So generally, when we talk about surveying, we try to look at the scientific or the systematic way of what? Of taking measurement. So when you go into your model, it says that is the act and science of making all essential measurements in space in order to determine the relative position and points. Okay, can you please mute your microphone? Okay, thank you. So when we talk about surveying, we try to look at the art and science or the science and art of making all essential measurements to determine the relative positions of places both on the surface of the earth, underneath the earth surface, and in the above the earth surface. So taking measurements or in surveying, when we look at surveying, we don't try to look at all the essential measurements that are done on the just on the surface of the earth, but then we include those beneath and those above. One will ask, what is beneath the earth surface that we need to survey? Now, we all know that we have minerals, there's soil, there are other things that people or that are of interest to humans that are not on the surface of the earth, they are underneath the surface. Now, once we are able to conduct these surveys, we know that, okay, we can find these things over here. For example, when one wants to drill a borehole, they don't just look for any space in their house, then begin to drill. But then they need to what? Survey the place. They need to find where in the compound or where on the land can I get water under the surface so that we can drill into it or we can tap into it. So that's why we survey under the land. So again, surveying is the science and art of making all essential measurements to be able to locate the relative position of places on the surface of the earth, underneath the surface, and above the earth surface. So we take note of these three items. Now, in the field of surveying, there are certain principles that guide us. There are certain principles that guide us. Now, these five principles, as I've highlighted over here, one is working from whole to part. Working from whole to part. Just a moment. Let me try and see if I can use this drawing. No, paintbrush. Okay. Okay. So I'm saying that the first step is working from whole to part. Okay. Now, what this means is that whenever we are taking measurement of something or we are trying to survey an area, it is important to take into consideration the bigger picture before we look at those inside. So we assume that we have this. Oh, Please hold on. Oh, sorry. So I'm back. So as I was saying, when you look at working from whole to part, we try to look at once we are, let's say we have this image or this drawing here, and we are to sketch it. Everyone, when I ask any individual to try and sketch this out, the first thing the person does is to draw the bigger box before they draw what the smaller boxes inside. Now, in surveying, in order to control what we call errors, we try to do what work from the whole. So we always create the boundary so that we can correct or we can reduce the number of mistakes or the number of errors that can come up. I hope you get me. So we always try to work from a whole before we come to the details or the nitty-gritties of it. It's just like drawing the when you're asked to draw the map of Ghana, there is no way you draw the region before you draw the outline of the map of Ghana. Please, I hope you are following.
Yes, sir.
Okay, great. So moving on, the next thing is ouch. The next principle is location of points by measurement from 2 points of reference. Whenever you are picking a point or whenever you try to take measurements, you always measure from point A to point B, making it 2 points. So if I want to get the measurement of a place, measurements are not taken from just one location. You will have to take into consideration at least 2 points, that is point A and point B, or point O and point A, whichever one it is. The third one is what we call consistency of work. And what do you mean by consistency of work? Whenever now, whenever you are putting things in order, whenever you are taking measurements, there is the need for you to make sure that you follow a particular principle. You follow a particular principle. If it's taking linear measurement and you want to use a tape, use the tape for the linear measurement. If it's taking angular measurement and you want to use the compass, you use the compass. But then you don't start with one, then along the line you change it and go and use another method. Then later you have to change again and go and use a different method. Um, let's say you are trying to prepare rice, or you are trying to prepare rice, and um, you are using Gino, or let's say Abena rice. Now you start preparing your food, then along the line you see that, oh, the Abena rice is not looking too nice. Let me add, please, which other type of rice is there? Peacock. Let me add peacock to it. Let me add this. So you realize that at the end of the day, there are so many things that have happened, then your food goes bad. The same thing applies in the world of surveying. When you are working, there should be consistency of work. If you are using one instrument for a particular task, use that instrument so that you'll be able to, when there is a mistake, you'll be able to what? To notice it. If it's a method, you also use the same thing and make sure that you'll be able to notice it. We have what we call independent check also. With independent check, what it means that whenever you notice or when taking any measurement, try to look at the work independently. So you pick point A, look at point A. Is everything okay at point A? Go to point B. Is everything okay at point B? Go to point C. Is everything okay at point C? But then you don't need to be mixing it up. You don't need to say that, oh, when I finish everything, then I am now going to check to see if there is a mistake or if there is something went wrong. Once you do that, your ability to correct mistakes or correct errors that may have come up becomes near impossible, because you wouldn't be able to identify what has happened. I hope it's clear. Next is accuracy required. Now, when we talk about accuracy required, you should look out for the proper method and instruments that should be used in what? In surveying. So similar to consistency of work. If you are using a pin, keep using a pin so that you know that, okay, whenever I use the pin, these are the errors that come up. And for each of the errors, it may be a 0.1. But then should you be using it up and down, changing it, then it becomes what? Very difficult to monitor it or to check it. Is that okay? The next one we have to look at, of all these, what are the importance of surveying? After speaking about all this, what are the importance of surveying? Now, one, surveying helps us to map places above and below sea level. When we talk about above sea level, we look at the surface of the earth through into the atmosphere. Then when we look at below sea level, from the surface of the earth down to the base or to the deepest trench in the sea. um, then that will be the Marina Trench. So one will ask, how are you able to know that, oh, this is the deepest part of the sea? Now that's also from what? Surveying. From surveying, we know that okay, these parts are the deepest. So when you are going swimming or when you go to the beach, try not to go here because this side is deep. Now that's from what? Surveying. Now because of this, we are able to prepare navigational charts that we use both on land, in the air, and at sea. Again, we are able to prepare property boundary for private and public land use. Had it not been for surveying, people would just own lands. By the time they realize, others will just encroach into their land and be building in their spaces without necessarily following the necessary procedure. So these, among others, are the importance of surveying. Now, to the history of surveying, there have been instruments that have been used, that have been founding fathers. I believe you are reading Geothought, right? Oh, I believe you read Geothought.
Yes, sir, we
Yes,
did
sir.
it in second year.
Yes, and you have not thrown it away because you use it. Oh,
Okay.
if you have thrown it away, please you go and look for it and come here because you need it. All right. So we call a surveying to the dioptra. All right, the dioptra. Now with the dioptra, what it does is, it's more of a surveying tool that helps to get the right bearings for location. Now this was by the work of Heron the Elder. So when we look at the history of surveying, it started from a place. Which civilization is known to have brought the compass or started the use of the compass? Which civilization? Emanuela, Edward. The question is, which civilization is believed to have brought uh, the compass?
Sir, I believe it's the Chinese.
Great. So the Chinese are believed to have brought or to have introduced the compass. Now, with this introduction, they helped what? To navigate places, or they were able to show bearings. Is that okay? Now, we have the dioptra as one of the tools that were used, and over the period, other civilizations came and they also what introduced theirs. So currently, we have the likes of um, the total station. We have the theodolite, we have the level, and the many others. Now, all these tools um, have evolved. Okay, and these ones all evolved from the basic tools that had been integrated or had been initiated from the past, just to get what the right measurement or to create boundaries. Is that okay? Now, in surveying, there are some basic geodesy and also some basic mathematical things that we have to look at. Let's try and transfer knowledge from um, is it thematic? Yes, thematic geography and earth science. What is the shape of the earth? Can anyone help with the shape of the earth? This I know you've been taught in earth science. I know this has been taught in earth science. So what's the shape of the Earth?
So I think the Earth is spherical.
It's spherical.
Yes, please.
Okay, but then what makes it spherical?
Oh, sir.
Yeah, I'm here.
It's the way it is being shaped. It depends on the shape, the way it is formed. That makes it a spherical.
Okay, I understand, but then what's what how is this shaped like? If you tell me it is spherical, I understand. But then what makes it spherical? How is it shaped? Or what gives it that spherical nature? I also understand my question.
Hello, sir.
Yeah, hello, I'm here.
Yes, please. Okay, I think it is spherical because it doesn't have any, should I say, corners or vectors. So it's like it goes round and it doesn't have, I don't know how to explain, but I don't know if you please, if you can get me. It is round in nature. It doesn't have any corners or something like that.
Hmm. Well, I guess I have to manage it like that. But then when we talk about the spherical nature of the Earth is not a perfect sphere. It's what we call a geoid, though. But then we've likened it to a sphere because it bulges at the sides. By bulges, it's like having a balloon. Okay, if you have a balloon or a balloon, and you press it at the sides, you will notice that it's more like the air tends to be, or the shape of the balloon changes. And this time around, the air comes, or the shape, there's more air at the sides as compared to the top and the bottom. Please, I hope you are following. Those of you who buy bread, when you buy bread, okay, I think there's a hand up.
Yeah. Hello, sir.
Yeah, Edward, I'm all ears.
Yes. Please, can you explain for us when you say the air is not a perfect sphere? Because
Okay,
all along we thought that it's a sphere. So if
okay. So, let me see. Just a moment. Let me try and see if I can get this for you. Sphere. Mm. Please, just a moment, okay? Let me share my screen so that I show you something. Um, it's our screen. Sure. Okay. Oh, okay. Please, I hope you can see my screen.
Yes,
Now,
please.
good. Now,
Yes,
when we
sir.
talk about now we talk about a sphere. It's a round, solid figure or its surface with every point on its surface equidistant from the center. Meaning, from any point in the center to the surface, it's equal. But then let's look at the Earth. Um, so true shape of the Earth. Okay, just a jiffy. I have this slide here I made for here once. Just a moment, okay. I have this slide here I use for here once. Okay, should be here. All right, found it. Okay, good. So please look here. So this is how we have idealized the shape of the earth. No be so.
Yes, sir.
So this is
Yes,
how
sir.
we've this is how we've idealized the shape of the earth. But in reality, this is how the earth looks like. Now, one who asks, why do we say this? Let's have the sun placed at this point and it should shine. You notice that not all the places within the equatorial region would get that insolation or would experience that heat that we have been talking about. But then when you look at this one, it's we are told that it bulges, so it's pressed at the top and it bulges at the sides. That's giving it this shape. So it's not a perfect sphere like this. We are not disputing the fact that the earth is a sphere, but then it is not a perfect sphere as we have been idealizing it. That's what I'm trying to put across. Is that okay?
Yes, sir.
Okay. Window, this one. Okay. Now, again, according to Eratosthenes, what is the size of the earth? Yes, according to Eratosthenes, what is the size of the earth? Hello, are we there? Or we've vanished?
So we are here.
No,
Oh,
no, sir. Yeah, yeah.
okay. So according to Eratosthenes, what is the size of the earth? You say I should go and
25,000 to 250,000. 252,000.
please come again. Hello, hello, are you there?
Yes, sir.
Yes, please come again. I didn't get you.
250,000 to 252,000.
So 250,000 to 252,000. And this is calculated by using what? The size of the stadia. Or that's equivalent to four stadiums. Is that okay? So we take note of that. But then that's just by the way. Now when you look at the size of the earth, or in terms of surveying, one will ask, what has the size of the earth got to do um, um, with surveying? Now with this, when we are picking a method for surveying, we are able to tell that okay, this is how the earth is. It is not flat. Okay, the earth is not flat, and the earth is not round like a ball. So when you are picking measurements, just know that oh, at a point in time, you would have to bend. You have to bend the lines at a point in time. You have to turn the lines at a point in time. You have to do this. So it gives room for what? For the various changes, for the various issues that can come up. Are we okay? Move me and to as well.
Listen.
Okay.
Oh, sir.
Yeah.
Yeah, I know.
Okay. Now, the next thing we have to consider again. The next thing we have to consider again are what we call the types of surveying. Types of surveying. As I mentioned, in the field of surveying, the shape and the size of the earth is important to us. Reason being that we need to be able to tell or understand that the earth is not flat like a ball. It's not round like a ball, neither is it flat like pancake. Is that okay? Now this affects the type of surveying or the type of surveying that we need to look at. Now, in terms of surveying, we have generally two types. We have what we call the plain surveying, and we have the geodetic surveying. We have plain surveying and geodetic surveying. Now, plain surveying is a form of or it's a type of surveying in which the curvature or the curvedness of the earth is not taken into consideration. Are we okay? Plain surveying is a type of surveying whereby the curvature or the curved surface of the earth is not taken into consideration. Now, this is very common. This is very common for short distances. This is very common for short distances. Whereas when we look at geodetic surveying, we try to look at the a type of surveying that takes into consideration the curveness or the curvature of the earth. Now, if you are asked, since all of you are in St. John's, it makes it easy. When the school park or the school field, when you are asked to take the measurement, or when you go to the school field and we ask you to, or we take the measurement of the school field from the pool or from one pool to another, it is easy. You notice that it will be straight, or it will be easy for you to what to pick it out. So you move from one pool and to the other pool, and it will be what? It will be flat. But then the question is, now when we ask you to pick from, what's the name of the building that you are in, where you have your lectures? What's the name of that blog? There's a funny name for it.
Cambodia.
Cambodia, good. Now, when we ask you to take the measurement from Cambodia to the far pole or the farthest part of the pole, you notice that it wouldn't be flat. There will be places that will be higher than the others. I hope you get it. So that is
Yes, sir.
where
Yes, sir.
good. So that is where the curvature of the earth comes into play. So it's not straight, but then you need to consider the curveness of the earth surface. We're good. So plain surveying, a form of surveying or it's a type of surveying, madam. It's a type of surveying that does not take into consideration the curveness of the earth surface, and usually it is done over a short distance. Whereas geodetic surveying is a form of surveying that takes into consideration the curveness of the earth surface, and usually done at a more far distance. So if the places or the points are far from each other, then it's important to take into consideration the curveness of the earth surface. Now, in surveying, there are some basic mathematical principles that we need to consider. We have geometry. Please don't stress your head about this. we don't ask you these things in exams or oh Jesus. There is outside. We don't take into we wouldn't be asking you that to tell us about the mathematical principles in surveying. What is geometry in surveying? What is this in surveying? No, we wouldn't be asking you those things. So please don't worry about it. All you need to know is in terms of surveying, there are some basic surveying principles. One being geometry, there's algebra, there's trigonometry, then there's Pythagoras theory. Um, these are terms that we use. Since you are doing a course, you might have come across, no, you have come across one or two of it. Is it okay? Don't to matter. Joy is outside. Is that what? Daddy said you should bring Joy outside. Okay. All right, take care. Please sorry about that. So surveying, in terms of surveying, we need to know these principles or some of these basic mathematics principles that are available. Is any question up to this point? Are there any questions up to this point?
Yes, so with this one, I can in the exams question, will we be allowed to answer questions like the hypotenuse and then the base?
No.
Okay.
We won't ask you to use the Pythagoras to solve for anything. No, we wouldn't
Mm,
do that.
okay. Thank you.
We like you too much to do that to you.
Okay.
All right.
Thank you.
You're welcome. I can see you don't like the mathematics cry.
So I like it, but I'm afraid of the algebra.
Hey, Francis, you like what?
And I'm also ready a Francis and Kwana Asaba. Well, let's proceed. Please, are there any other questions before we move to unit 2? Are there any questions before we move to unit 2? Please hold on. Let me bring my dog inside before he runs out.
What's going on here? Hello.
Hello, sir.
Hello, sir.
Hello.
Yeah. Hello.
Hello, sir. Yeah, here.
Okay, sorry. I hope you didn't do a coup behind me.
No, sir.
Okay, thank you very much.
You are
Okay,
welcome.
Okay, sir.
so let's continue. Now, for unit 2, I'll be dividing it into 2 sessions or into 2 groups. We'll be looking at we'll be looking at the types of surveying and the classification of surveying and the surveying instruments. Let me see. Okay. I want to see if I can use this thing for you so that it looks easier. So word. Let me share this thing. Okay. Please permit me. I just want to make everything very easy for you to understand. That's why doing. I'm just trying to take my time with certain things. Okay. Okay. All right. So I'm almost there. And present something else. And I will do it. Okay. Please, I hope you have opened your models. You have your models with you.
Yes, sir. Yes, sir.
Okay.
Yes, sir. We have.
Now when we look at surveying, the classification of surveying, we have 1, 2, 3. True of us.
True.
Okay. Now, with the classification of surveying, they are put into 3 groups. They are put into 3 groups. So we have the first one. So we have this so 1, then an arrow, then I'll just replicate this box 1, 2, 3. 1, 2, and 3. Let me do it this way for you. Okay. Now with the classification of surveying, we have 1 based on the type of instrument. That is for instruments. Okay. So if you look at the unit 2, session 1, we have the classification of surveying based on the instruments used. The second one is based on what? The purpose, right? Oh, okay. Then the last one is based on the method. So please, from where you are, you can try and put this diagram there. You can just draw this diagram small there so that it helps you understand everything in that zone. Doing well, so okay. Okay. Now, when we pick surveying into classes, one classification is based on the type of instrument being used. Now, based on when you look at based on the instrument being used, we say that okay, if you are using a hammer in surveying, then you'll be looking at it in terms of hammer survey. But this time, when you look at the instruments used in surveying, we don't have a hammer. So we try and name the surveying the instrument you are using. So over here we have the likes of chain survey. So chain survey means that we are using the chain instrument in surveying. We have compass survey, which means that we are using a compass in surveying the area. Is that okay? So for the first one, based on the instrument that is being used, we try and say that okay, if whatever instrument or whatever tool that you are using in the survey, then we name the survey after it. So one we have so um under the type of instrument, surveying the classification based on the type of instrument. We have chain survey, we have compass survey, we have level survey, we have total station, we have GPS survey, among other types of what? Other types of survey. So one classification is based on what? The instrument you are using. Now the second classification is based on the purpose. What are you using the survey for? Are you using it just to know the features on the Earth surface? If that is what you are doing, then you'll be looking at it in terms of what? Topographic survey. If you want to use the survey to find where water is located, then you'll be looking at it in terms of what? Hydrological survey. If you are using the survey to map, to get boundary lines. Okay, so let's say someone is going to buy a land, they prepare a map showing the boundary that the person's property falls within. They will be looking at it in terms of what? Cadastral. If it's for mining activities, then it will be known as what? Edward. If I'm picking,
Sorry.
if I'm picking, yeah, if I'm picking measurement for the purposes of mining, then one name will be given to it.
This one here.
This one has not done anything. Let me take it again. When we look at the classification of surveys, okay, one is based on the instrument we are using. Do you understand that one?
Yes, please.
Okay. So let me ask, if you are using a compass to survey an area, what name would we call that type of survey?
So it's a
Compass
compass survey.
survey.
Good. It will be a compass survey.
Yes.
What if I'm using a chain?
Chain
Chain
survey.
survey.
Good. Now, the second classification is based on the purpose of the survey. Why are you surveying?
For mining purposes, for other
You
purposes.
get it. Uh-huh. Now, if the survey is to know the route of a river, where water can be found under the surface of the earth or on the surface of the earth or anything about water, how do you call water? Like in general, how do you call water? In geography, how do you refer to anything water?
Hydro.
Good. So in
Hydrology.
geography, good. So if I am conducting a survey to know where water is, then you can term it as what?
Hydrological survey.
Hydrological survey.
Good. Now this time around, I am conducting the surveying to know where minerals are located so that I can go and mine them. So what type of survey would that be called?
So that would be the
Mining survey.
geochemical.
That would be what?
Mining,
It
mining survey.
geochemical survey or
No, that would be mining survey.
Mining
Geochemical
survey.
is so it will be mining survey. Is that okay? So you
okay,
take
sir.
Yes.
note of that. Good. So cadastral for boundaries. Then what of I'm trying to survey the area to know the mining spots and to know where I can grow certain crops.
Agriculture survey.
Agricultural survey.
Yes.
Is that okay? So that is how it moves. So when you look at these kind of surveys, you see that they tend to be based on this classification, the type or the purpose why you are conducting the survey is used to name or it influences the name that is given to it. Then the third classification is based on the method you are using. The third classification is based on the method you are using for the survey, such that if you are conducting the survey on the ground, on the surface of the earth, it is referred to as ground survey. If it's on the surface of the earth, it is referred to as ground survey. If it's conducted under the surface of the earth, it is regarded or it is referred to as underground survey. Then if it's done above the surface of the earth, it is regarded as aerial survey. I take it again. All forms of survey that occur on the surface of the earth are referred to as ground survey. All those that occur above the surface of the earth is referred to as aerial survey. And those that occur under the surface of the earth are referred to as underground survey. Please, I hope it's clear.
No, sir.
Yes, sir.
Good. Any
So
question
you
on
see,
that? Mhm.
with the one you said on the surface of the earth, you said it is called the earth survey, and then
No,
the
ground.
under the ground too is the underground survey. But why is it that I thought you said above the earth level? I think it should be top survey, but now you are saying it is area survey.
Okay. So we don't have anything like top. When we say something is aerial, it means that it is not on the surface of the earth.
Okay,
So,
so
yes, it's like when we say an aerial picture or an aerial image, it means that there is something up in the sky and that thing has taken an image of the place. Okay, that's why it's called aerial, not
okay,
not top.
okay, thank
So
you.
you're welcome. Please, any question before I proceed? So in terms of the classification, as I mentioned, three, you have the instrument, you have based on the instrument, based on the purpose, then based on the method. Okay. Okay, back to this. Now the next thing I want us to look at is the types of instruments. The types of instruments. Now, when you look at unit 4, 5, and 6, this is how it's broken down. Sorry, section 4, 5, and 6. Section 4 looks at the instruments that are used to pick linear measurements. Instruments that are used to pick linear measurements. Section 5 looks at instruments that are used to pick angular measurements. The angular measurement. Then section 6 looks at instruments that blend the two. Is that okay? So
Yes, sir.
let's take it from the top. Now with instruments that are used to pick linear measurements, we have the chain and the tape. We have chain and tape. Now the chain is just a metal, it's made of metal. Okay, some are made of brass, others are made of alloyed materials. Now, it's a device or it's a tool that has two handles. Oh, what's wrong with this? It's a device that has two handles. Okay, so two handles where you can hold it. Then it is made up of metal bars that are interlocked to each other. Based on the type of chain you are working with, it influences the length of it. So not all chains have the same. Oh, not all the chain. Please hold on. John. John. All right. So all chains do not have the same length or the same measurement. Okay. All chains do not have the same measurement. Now, based on the type of chain, either it being a Ganter's chain or an engineer's chain or a steel band chain, that influences the length of it. But then all chains have handles. All chains have what we call what? The links. Now the links serve as how do I put it? A measurement. So let's say if you take a tape measure, you're able to see 0 to 10 centimeters. But then when you take a chain, you wouldn't see the writings on the chain. But then we use what the link to show the measurement. Are we okay? We use the link to show the measurement. So based on the type of chain, it influences what? The length of it. Are we good? Then when it comes to the type of chain, we have metric, we have the Gantes, we have the steel band, we have steel band, sorry. Then Gante, engineer, revenue, and among others, there are many of it. Then we have tape. Now, tape is more like the normal tape measure that we know. When we step out there and we use we are trying to pick measurement. Customer no about let me if you don't know. Oh, okay. All right. So proceeding. When you look at the tape, based on the material or the type of material that is used to make the tape, they rename the tape after it. So if the tape was made of linen, we will call it what? The linen tape. If it's made of woven metallic material, we call it what? The woven metallic tape, as well as many others. So when it comes to tape, it has a handle, a single handle. One person holds on to it, stretches it to the far, then the demarcations are on it. So the tape and the chains are used for picking linear measurements. The tip and the chain are used to pick linear measurements. Whereas when we want to look at angular measurement, we will take into consideration the compass and the leveling or the level device. Now, compass, it is mostly handy, something that you can easily hold, carry around, and move. Now, with the compass also, you're able to look through. So it's a device that has a flat disc, and on the disc are demarcations or divisions of which when you look through from one point to the other, you're able to see the angular measurement. So if from point A to point B, you're able to tell that, okay, the angle from point A to point B is maybe 210 degrees. Please, I hope you are following.
Yes, please.
Good. Then the same applies to the level. When you look at the level as a tool, now the level is more like an advancement of the compass. Reason means that the compass you can hold and put in your pocket and be moving around. But with the level, this time around, it is more stable. The level is more stable in that when someone mounts a level, it can stay at one location so that whoever comes, irrespective of where you are coming from, you always see what that particular what do you call it? You always see that particular measurement. So if I use a compass, if I should pick a compass and pick out a measurement, chances of me getting a different result from you is very high. But then if it's a level, the level it is set on what we call a tripod. Some of you call it tripod stand, but then the right name is just tripod. Now it is set on a tripod, so it is static. Once you set it, the next person who will come will just have to look through and you are good to go. It's okay. So the compass and the level are used for picking angular measurement. And in terms of angles, you can look at the whole circle bearing and the quadrantal bearing, which I think we'll be looking at in the subsequent classes. Then the third one is what we call the total station and the GPS device. Now, the total station, we are told, is a modern surveying instrument that integrates an electronic theodolite with an electronic distance meter. So the theodolite, the total station does two things. It takes both the angular measurement and the linear measurement. So one device can take the measurement for a straight path and at the same time take the bearing of a place. Whereas the GPS also does the same, but this time around, you need some form of computation to be able to get the other forms of what? Of the measurement, or you get the other forms of the readings. So yes, you get the linear measurement, you get the angular measurement, but then if you are using the GPS device, it means that you have to do some form of mathematics or internal computation so that that same instrument can get you the linear and the angular measurement. This I hope is clear.
No, sir. You have, please take it again.
Okay. So which of them is it, the total station and the GPS device?
Yes, please say the total station.
Okay. So I'm saying that with the total station, it is a device that integrates the linear measurement and the angular measurement. Remember that when I was talking about the tape, I said that it can help you get the linear measurement. and the compass will help you get the angular measurement. But then when we look at the total station, it does the two things. It does both the linear measurement and the angular measurement. I hope it's clear.
Yes, sir. I'm okay.
Mm-hmm. Who else is not okay? Okay, so I believe now everybody is okay. That's fine. Then when we talk about the GPS device, this one is more of a handy tool that you can carry around anywhere. It can do, or it does both the linear and the angular. Okay, it does both the linear and the angular, such that with the linear measurement, it can help you locate. Also, first it picks the points or the location of points. Then while upon computation, it can link and help you get the angular measurements and the linear measurements. Unlike the theodolite, unlike the total station, once you use the total station, you're able to get what the direct angular and linear measurement. But with the GPS device or the GPS, it takes an extra step before you get those information. Please, I hope it's okay now. Hello.
Yes, sir.
Yeah. Please, I hope you're
Yes,
okay.
Yes, sir.
yes, please.
All right. Okay. So if everything is clear, I think we can call it a day for today. Let's try and arrange a day within the week so that we do the unit 3, and then perhaps we can proceed with the others. Is that okay? I think we'll need to get the class list so that I can prepare adequately for the presentation. Know what and what, like the people that you are dealing with, so that I don't make mistakes anywhere. Is that okay? Are we fine?
Yes, sir.
All right. Are there any questions? Are there any questions? Okay. So if there are no questions, I say a big thank you for making time for today's class. And I look forward to hearing from you guys soon so that we can proceed with the others. Thank you.
You're welcome. Thank you, too.
All right.
Thank you, sir.
Thank you, sir.
Thank you.